Okay, so this is the first problem where we're going to practice using the chain rule to differentiate the given equation. Okay, so you have two functions. Remember, we have an outer function, and in this case it's going to be the function that raises the expression to the hundredths exponent, and then we have an inner function, which is the inside one, so it's x to the third minus 1. So when we differentiate, which is we finding derivative of y with respect to x, we have to first take a derivative of our outer function. So in this case, it's a function that raises something to the power of 100, so we have to use the power rule. So the power comes to the front, and then we subtract 1 from the power. And notice that our x to the third minus 1 just stayed the way it is here. Then we have to take the derivative of the inner function, which in this case is the red one. So the derivative of x to the third minus 1 will be 3x squared. So this is the derivative of the outer function, and this is the derivative of the inner function. So then all you have to do is just simplify. So the only thing I'm going to ask you guys to do here is to multiply these two together. So 100 times 3x squared will give you 300x squared, and you are going to leave x to the third minus 1 raised to the power of 99. So that's your answer. Alright, so here's another problem that we have here. If you want to pause the video, you can, and try to do this on your own, and then hit play to see if you got it correct. So here, we are trying to find the derivative of the f function with respect to x. And what I am going to do is I'm going to rewrite this with the power using exponent. So it's a cube root, and it's in the bottom, so it's negative 1 over 3. So our outer function is the one that raises something to the power of negative 1 over 3. And then our inner function is x squared plus x plus 1. So when we're looking for the derivative, we have to first take the derivative of the outer function. So this is going to be a simple power rule. We take our power, we bring it to the front. Alright, inner function just stays the way it is. Then we have to subtract 1 from the power. So some of you are making a mistake on the quiz with this, so you have to be very careful. You have negative 1 over 3, and you're subtracting 1, so you're really subtracting 3 over 3. So you now have negative 4 over 3, so that's your new exponent. So now we do have an inner function, and we do have to take the derivative of that. So the derivative of x squared plus x plus 1 is 2x plus 1. So now what I'm going to ask you to do is rewrite it and simplify as much as you can, and we want to try to avoid negative rational exponents. So what I'm going to have you do is the following. So it's going to be negative 2x plus 1 over, we have the 3 that goes on the bottom, and then we have x squared plus x plus 1 to the power of 4/3. Or if I ask you not to use rational exponents, you can also write it like this. So you can use cube root of x squared plus x plus 1 to the power of 4. So depending on the wording, you can use either one, and I would make sure that I make it clear whether you can use rational exponents or you can't. Alright, so here's another one for you. We have so we have our outer function, which is the one that is going to raise something to the power of 9, and then we have our inner function that is a fraction. Now you do have to use a quotient rule here when you find the derivative of the inner function. Okay, so we are going to find the derivative of g with respect to t, and our first goal is to take the derivative of the outer function. So in this case it's 9 t minus 2 over 2t plus 1. We need to subtract 1 from the power, so this gives us 8. And then we will have to take the derivative of the inner function. And we don't have x, we have a t in here, so we're taking the derivative with respect to t. Okay, so this derivative right here is the derivative of a quotient, so we do have to use a quotient rule here. Okay. So we still have this, that didn't change at all. And then I'm going to use a quotient rule. So remember, the quotient rule tells us that we need to take our bottom function times the derivative of the top, which is 1, minus our top function times the derivative of the bottom, which is 2, and it's going to be all over 2t plus 1 squared. Okay, so let's see what this gives us. So first of all, we have this 9 here, and then if you notice, this has a 2t plus 1 and this has a 2t plus 1, so we can actually combine them together, and we're going to have 10 of them because this exponent is 8 and this exponent is 2. So if we combine them, it gives us 10. And we still have our t minus 2 to the power of 8. And then we have to simplify this right here. So what I'm actually going to do is I'm just going to do it on the side so that I don't have to keep rewriting all this other stuff. So on the top, we have 2t plus 1 minus 2t plus 4. And the 2t and negative 2t will cancel and we'll just get a 5. So all of this will simplify to a 5. And I actually can just multiply the 9 by 5. So I'm just going to write it. So 9 times 5, and that's going to give us 45. So then I could just erase it and write 45. So that's your answer for the derivative. Alright, so this is going to be our last one here. Okay, so we have a little bit of craziness here. So we have a product, and we also have this is a composition of two functions, this is a composition of two functions. So we have a product rule and a chain rule. Okay, so first of all, let's notice that we are multiplying two polynomials together. So what we need to do first is we do need to use the product rule. So the product rule tells us that we have first function times the derivative of the second function plus the second function times the derivative of the second function. Now, when do you have to use a chain rule? We will have to use a chain rule over here because we have a composition of two functions, and we will have to use a chain rule over here. Okay, so let's start. So first of all, we have 2x plus 1 to the 5th from before, and then this is a outer-inner function. So the outer function is the power of 4. So derivative of this is going to be 4 times x to the 3rd minus x plus 1 to the 3rd power. And then we still have this inner function, so it needs to be multiplied by the derivative of this inner function, which is 3x minus 1. So then we have x to the 3rd minus x plus 1 times, we have to use a chain rule here, so it's a power rule again, so it's 5 times 2x plus 1 to the power of 4 times derivative of the inside, so times 2.